Hey, happy Sunday. This is PFG Live. Welcome aboard. Today it's March 23rd, and you're not. Welcome to everybody in the chat. Let's see, we got a bunch of people just checked in. DBX is with us from White Plains, New York, at the White Plains Airport in bathroom number 7. Winds are 300 at 13, gusting 17, 10-mile visibility, and clear skies. Evils from Ghent, Belgium reports 23.0 degrees in his kitchen. Josh is with us. He says audio check in PFG Flat, Southern Manitoba. We were talking about you. Dale and I were talking about you and where you live, and it is PFG Flat, where it is presently. Winds are 300, 11, gusting 16, temperature minus 06, dew point minus 13, and the remarks say that there was wind. Whitten is reporting from Echo Hotel Kilo Delta. Wow. Winds are 020 at 3 knots. Skies clear. Overcast at 14,000. Wow. Temperature 12, dew point 09, and other European things. Dale says it's 3 degrees science from Edmonton, Alberta, Canada. Tucker in the Buffalo, New York says it's 36 degrees Fahrenheit and cloudy. It was chilly this morning. I went out for my walk and I came back early because it was a little cold. CJ Stevens is with us. Welcome aboard, sir. He says it's 70 degrees and sunny in East Tennessee. He's doing electrical work today. RJ's Workshop is with us. He says it's a beautiful spring day at 7,500 feet in southeast Wyoming. 37 degrees, at least it's over freezing. Sunny, light winds, southwest at 28, gusting to 45. Light winds. I think that's not exactly what you meant. CJ reminds us to hit our like and subscribe buttons. Thank you, CJ. We appreciate that. Proteum Machining, Dylan is with us. He reports 76 degrees Fahrenheit and 10 degrees relative humidity in his filament dryer. No, in Tucson, Arizona. Pretty much the same thing. Steve Tessier reports the METAR from KCSG, which is Columbus, Georgia. Winds are 170 at 9 knots, gusting 14 knots, 10-mile visibility. Foxtrot uniform, same to you, buddy. Clear at 22 degrees, and it's lovely. Paul Morley is checking in at 75 degrees in Dallas, Texas, and we were just talking about hard-inch lathes, which, one has to talk about those things. Arthur Johnson is with us. Welcome aboard, sir. Nice to see you. 41 degrees and sunny in Massachusetts. You could tell me where. I won't pick on you for exactly where in Massachusetts you are. RJ says that the 45-mile-an-hour gusts is light for March in Wyoming. I will believe you. Carl Tauber says it's 41 degrees and sunny in the People's Republic of Rhode Island. The Discord is NFG, but YouTube is PFG. So welcome aboard, Carl. We'll figure that out. You're in Cambridge. You're not at the institution that I'm familiar with, are you? Welcome aboard. Well, we had a busy week here. Lots of stuff going on. If you're on the Discord, we frequently check in on the shop voice channel and hang out together. Those of us who are busy in the shop, and it's kind of nice to get to keep company and talk about nothing at all. And when you're alone, and we're going to talk about starting a business, and many of you are possibly thinking about it or in one-man shops or, small businesses, it's nice to have somebody to talk to that understands what you're doing. So sometimes if you get, if nobody's around for you to complain about the drill you just snapped, just tune into the shop voice channel and we'll find somebody to counsel you. So today we're going to talk a little bit about standards and calibration in the small shop. It's an interesting topic, and we'll go deep in that. And we'll talk a little bit about starting a business. I was reminiscing, and that came out of a Discord conversation also. We were talking with one of our buddies. He's not here, so I won't identify him. But he was asking specifics about starting, how much should he charge and how should he structure charges and that kind of thing. And that led me to thinking that other people might have the same questions. So it's worth talking about. Just by a show of hands in the chats, how many people make money from their shop? Just raise your hand, and there we go. Dale, of course, we know that. Who else? Josh has made money in his shop. I know that. Protium does very nice work, I could say, because he has some of my money and did a great job. DBX loses money. That's just making negative money. So that's okay. That's good. Quentin once, he says. So Quentin, once you get that EDM up and running, you'll be doing it. Art that makes art, of course, he's doing it. CJ Stevens says it's side money. Stephen Tessier said made money, but not in the positive yet. 1 year in a few months. Keep going, man. You're doing it right. Dale says, at least I'm supposed to. Not always. Yeah. So, my trek into my machine shop was via making money a different way. I was doing my antenna consulting, and the machine shop became a necessity to build my prototypes, and that's how I ended up in the machining world. And then, as a side effect of that, now we make money in the machine shop also. Not only making PFG stones, which is a specialty item, but some of my clients come to me and they say, hey, could you make, 20 of these for us? And I do. So, but I'm not a job shop. Somebody once asked me, how long have you been in the trades? And I had to say, well, I don't really consider myself in the trades because I'm not specifically doing trade work. I'm doing consulting, engineering consulting, and this is sort of a side effect. So it's weird. So now we have the guy upstairs in the antenna department and the guy downstairs in the machine shop, and they argue incessantly. But that's just the way it goes. So we'll talk about that. And the third thing is we have a 3D printing update. I might start with that, actually. And if you guys have questions, topics, which one works more? Good question. They argue about that also. So honestly, Paul, it depends on the week. And I have personally, this is my story, right? PFG Stones have usually been my Friday thing, right? So on Fridays, I'm in the shop to the point where my thermostats are programmed to warm up the shop every Friday morning. So that has expanded. So now I do, I'm in there on Thursday, but not all day, but it depends on the workload. Similarly, up in the antenna department, I've sort of been intentionally slowing down. I've been saying no to a lot of projects, but there are some projects I've said yes to, and that's still keeping me as busy as I want to be. I have one project, you know who you are. I have one project now that involves all three floors. So it's the guy in the antenna department, the guy in the machine shop department, and the guy in the 3D printing department all have input on this project, and they're all busy, and they're constantly at each other's throats. So, and the pedal department. We have not started the pedal department yet. Oh, while I'm at it, is it okay if I show some of the things that you and I are talking about there, DBX? I need your permission before I do this. So we were talking about, here's a topic that you didn't see coming. We were talking about guitar pedals, guitar pickups. He was joking about guitar pedals because we're also talking about that. It turns out that guitar pedals have their, and pedals are special effects things, have their roots in analog electronics of many years ago. And my brain works in that mode in analog electronics. So we've been talking about what pedals do and looking at schematics and stuff. But the thing that I was quite interested in were these things. And I don't know how many of you know what I'm holding up here. This one is upside down if you care about the trademark. It's IBZ USA. These are, anybody know what these are? And DBX, you can't answer. Ibanez? Oh, is that the name of the company? Ibanez? That's right. Tucker knows. These are called pickups. Okay, this is what goes under the strings in an electric guitar. Evil says magnets in a trench coat. You are also not incorrect, sir. That's about right. And because I have some background in magnetics and magnetic sensors, and in particular magnetometers, I was very interested in these. Well, DBX sent me these, and I started staring at them and messing with them, and I have some opinions, but I won't bore you all with that topic right now, except to say that this is pretty interesting stuff. And you know, they are magnetic. There are magnets involved, which is why I have to warn Unix Carbide that we might talk about magnets today, and therefore I don't think he showed up. So that's we'll be talking about magnets and guitar pickups. So talk about that guy arguing with the other three. It's out of control. So let me jump to 3D printing update and show you a couple of pictures. So how many of you have the Bamboo X1C or cousin printer? Tuck does. I know that for sure. DBX does. You don't even have to tell me. Who else has one? I think a bunch of you got one, and we've been very happy with them. I have yep, Quentin, Steve, yep, Wes, cool. So I have a print farm. I don't usually call it that, but I have 3 of them. They make all the trays. They make accessories. We'll show off this guy later, but they make all sorts of other important accessories for my my precision machining, and they've been great. They've been great. One of the things that happens in an X1C is that the PTFE tube that feeds the extruder head, as the head's banging around, that tube tends to rub on the glass on top of the printer. And if you have an AMS, and if you have an X1C, you have an AMS, the AMS sits on top of the glass. So the rubbing of the PTFE tube that feeds the filament to the extruder is real. And in fact, I did some observations today, and the Teflon is literally rubbing off onto the glass. The tube is wearing, and there have been ample reports of people who have just worn that tube out, and then the filament was getting stuck and, of course, causing a jam. I did notice, especially on printer number 2, a flat rub mark on that piece of PTFE. So I was looking for a way to raise the glass up on the X1C. Oh, it happened to Tuck. Okay, thank you, Tuck. Yeah, take a look at it, Paul. You could print for a long time and not have a problem, with it. Thank you, Dale. Dale's Johnny on the spot. There's a picture of the glass on top, and the PTFE tube touching it. It's normal. It's not an abnormal behavior. But look at his picture, because I have one also. Look at his picture there that he just put in chat. You see those white marks there? Those are on the glass. That's Teflon being left from rubbing on the glass. I just cleaned up 2 of them. So I went looking through this one I found in printables, and it's a riser for the plate, but it's also brackets that hold the AMS, and they have little fingers that grab the AMS, so the AMS is rigidly held, and it works. It does exactly what I wanted. It clears the glass, clears the tube, but then I realized other benefits, and I love this thing. Okay, so here's another shot. If you're on the audio podcast, I'm just giving a tour around this print on top of my X1C. It raises the AMS off the glass, it moves the AMS back, and it also gives you superior visibility looking down into your printer, which is awesome. Oh, that's interesting. Jeff says he has the Queedy +4, but put a riser on the case to stop the rubbing. Same problem. He says he also built a vent slot into the riser that connects to the vent so fumes go out the window. Excellent. I did find a little hole. If you look at the back, right above where the filament goes into the case, there is another little notch there, which I haven't figured out, but there it is. So here's a couple of other pictures of the first riser as it went in. Again, it worked great. So it's printed in 4 pieces. There's 2 pieces that you print 2 pieces on one plate, 2 pieces on another plate, or another batch, and they have dovetails and they just slide together, and it works fantastically well. Was it a world-class print? No. There's a couple of little dinkuses in there, but I don't care. It does exactly what it's supposed to do. Dale asks, what material did you print it in? So I use a special material for these kind of projects. It's called whatever I could reach first. Yeah, we have a little joke running there. But actually, this was printed in PETG black because I had, wait for it, PETG black. Yeah, Tuck says his riser has the same notch. So I put the link for this riser, which is on printables, into the chat on Discord in 3D printing. So if somebody wants to grab that and put that into the video, that'd be great. I'll try to add it to the descriptions. So here's a feature that this thing has: is you could take the glass and you could lift it and to look in or whatever, or you could pull the glass out and put the glass onto a little shelf that's built into the riser, and if you need more ventilation. I actually considered that for today, and it just works. You just print it and you use it. It's fantastic. Thank you, Evils. It's the AMS glass separation riser with front rim by Ken Mills, M-I-L-S, and that is on printables. That's because it's a video right there, which we're not going to play. Okay, and that's it. So that was a big win. Paul says, would a couple of well-positioned pieces of UHMW tape on the underside of the glass eliminate the rubbing? It's a good question, but then you got you got tape on your glass. I have to say, one of the absolute best side effects of this that I didn't see coming was the magnificent visibility now from the top. And it is great, because I often want to look in the printer and make sure everything's well behaved, and it's, things are a pain in the neck the way I had it before, and this makes it easy peasy. It does fit on a P1S, but just read the printables entry. He could have a little more documentation in there. I just gave it a shot, and it was a winner. Winner, winner, chicken dinner. So that's what that was going on in Prusa land. I mean, in in bamboo land. Um, Protium says, I wonder if they addressed it on the H2D. We don't know. We will find out. So in 2 days, I guess Bamboo is going to release the new printer, right? Or the details on the new printer. So we'll find out what that's about. I am considering another one, another X1C, because I have a client that needs some bandwidth, some printing bandwidth. So I designed a print farm for him, a 4-printer print farm, and then I realized, I think it was this morning, maybe last night, I realized I have 3/4 of a 4-printer print farm, and I have the table that I suggested. So I may rearrange things in the 3D printing department to be exactly what I just recommended to him, which is 4 X1Cs on a Husky table from Home Depot, already spec'd, with a UPS of a certain size underneath, which I almost have, and ready to rock and roll. So I may buy one more X1C. We'll see what happens. So stay tuned. We will report on the new printer coming from Bamboo. Heated AMS, we think. Dual extruder, we think. They've been leaking stuff to get us excited, and it worked. So any other 3D printing department stuff that you guys have that I should be talking about, let me know in the chat. Otherwise, I'm going to change gears here and talk a little bit about, I think we're going to go backwards here. We're going to go into starting a business and talk about business stuff. And then the last thing we'll do is get into standards and calibration, if that's okay with you guys. So we were having this discussion about one of our members sort of looking to start taking on some jobs and doing some stuff in a one-man small shop. And he asked questions that were pretty important. It's like, how do you charge? What do you charge? How do you price it? And I know Dale was jumping in because Dale's been a one-man band now for quite a while, and he has a sizable shop. He does big parts. 13 years, holy cow. And is it fair to say you're servicing some of the oil field guys in Alberta? We see a lot of that go through, but really there's a lot of industrial stuff goes through his shop. So we had a really good conversation. And if I say anything wrong, Dale, you just slap me. The way I approach it is, are you developing something for a client, or are you making a thing that they almost have a drawing for? The development work where somebody comes to you and says, I'm looking for an example on my desk here. Somebody comes to you and says, look, I need a way to, I need something to hold this thing, and we don't know how to do it. And you have to then do measurements, do maybe even 3D scanning, generate models, measure the stuff up, come up with a design, what we would say is a design, maybe in Fusion or SolidWorks, whatever your tool is, and then make it, right? Then go and machine it and make it. You are doing 2 jobs. You are doing engineering and design, and you're doing machine shop work and making the thing. Evil says blob of hot glue. There's a limit to how much money you can get paid for a blob of hot glue, Evils. I think we need to engineer this thing. So my advice is you split those things. And in fact, on my rate sheet, there's 2 different rates. There's engineering, and then there's production of machine shop stuff. And you have to use your judgment. If it's, I need a bracket, okay, yeah, fine. Maybe you don't have to charge a bunch of engineering. But if it's, I need a vacuum chamber, Do you have a drawing? We have no drawing. We have no idea how to do this. That's engineering. So the ratio between my engineering rate and my machine shop rate is over 2-to-1. In case you didn't know, the engineering is more expensive. Just I want to clarify that. So that's the first thing you have to decide. And of course, I was doing consulting. I was doing engineering consulting for years and not charging for shop work per se. And then later, all of a sudden, it became a thing. So it was normal for me to say on the engineering side, oh, that looks like, 40 hours of work. Because in my experience, that's what's going to take. Here's my engineering rate. A times B equals C. Here's a quote. Right. So Dale says he's the other way around, but you're shy. So Dale's shop rate is more expensive than your engineering rate. Is that what you're saying? Yeah. Dude, you got to get into antennas. I'm telling you. But I digress. So let's set aside the engineering rate for the moment. The shop rate, yes. Okay, Steve, this is for you. Steve says, I don't have rates. This is for you. You're going to have rates by Monday morning, okay? So the way I look at it is you have to start somewhere. So it's like a machine plus operator has to make $100 an hour, okay? And I want feedback from you, Protium, because these might be considered too low. And because Protium is in the, smaller, faster sort of work, Dale is in the bigger, lower numbers kind of work. Okay, 250 for Dale. Okay, got it. And I've upped my expectations to Protium says, I've seen shop rates from $75 to $400 an hour in Tucson. That's a big range. So what we're talking about is in that range. So I've sort of drifted up to about $150 an hour, machine plus operator. Wes says, you guys make money? We try, Wes. We try. Talk to us at the end of the year. we do try. So machine plus operator, $150 an hour. You can go higher, you can go lower. It depends on the machine. So vertical machining center, no problem. CNC lathe, like the tool room lathe, no problem. The grinder, I think you get more higher shop rate on a grinder. There's a lot more skill involved. It's a lot more specialized. You have to go up. So that's kind of how I quote things to a client for a job that I want to do. Put an asterisk on that. So I look at it and say, well, you don't really need any engineering. You kind of handed me a drawing. It's not a great drawing. We'll fix that. And you want 5 of these things. So I'm going to buy material. Okay, I'm going to do all these other things. And it looks like preliminary pencil on back of envelope says that that's a 4-hour, 5-hour job or 10-hour job or 20-hour job. Here's what it is. Now, that's a pretty good way to start. Protium says when you're starting out, it's easier to benchmark it from cost plus materials plus markup. Once you grow and establish a niche, it's harder because you need to be charging based on the value you're providing to your customer. I would agree with that. That's why none of this is easy. There's another rule which I like to teach people called the Hewlett-Packard rule. Back when Hewlett-Packard was Hewlett-Packard, and they made actual engineering tools, measurement tools, magnificent measurement tools. They made medical devices. They were a fantastic company, and then they got split up. And the thing that always hurt my heart was that the Hewlett-Packard name went with the computer company, And then the non-Hewlett, the non-computer stuff became Agilent. Well, Agilent later became Keysight Technologies. And it's just sad because HP was a magnificent instrument company. And I still think of them as HP. So they had a rule which was, how do you price one of their instruments? You know, they're in production. This is something in production. This is not job shop work. This is something in production. And my rule is 5 times materials, or 3 times materials plus labor. So 3 times materials in parentheses plus labor. So remember those, you know, there's a human rate that the human's going to get paid. So on your spreadsheet for this job, you do the first kind of calculation, right? Engineering time, shop time, you come up with a number. The next column over is 5 times materials. The next column over is 3 times materials plus labor. And then you stare at it and you have to make a decision. Where is it going to fit? If all those numbers converge, it's pretty simple. You have a safe number. If those numbers are horribly different, you have to scratch your head and figure out what's going on here. But there's an old ancient proverb about, you know, the expert being called to the factory because, you know, the production line is down because this big machine isn't working and they can't figure it out. And the expert comes in, and after, you know, walking around and poking things and listening to the machine, he walks up, sets up a ladder, climbs up the ladder, takes out a piece of chalk and puts an X on a panel. And he says, right behind this panel is your problem. You need to do this. So they open up the panel, they verify that it's exactly what the expert said, and they fix it, and everything's working. And they said, thank you so much, please invoice us. So he sends an invoice for $10,000. And the CFO calls him up and says, hey, can you just give us a little more detail on the invoice? And he says, sure. Piece of chalk, $1. Knowing where to put the X, $9,999. So if you're in a situation where you are the expert and you are bringing your magnificent expertise and experience to the problem, you have to charge for that. And it's an intangible. So it's almost a what the market will bear kind of number, but that's a different category. Let's see. Dale also says you have to take into account consumables. If you need a $5,000 tool to make the job happen, do you need a $5,000 tool to make the job happen? Are you risking damaging a $5,000 tool to complete the job? He goes on to say, it's part of the reason I have to charge as much as I do. Tooling for aluminum is not nearly the same cost as tooling for Inconel. Or the only one that answers the phone on Friday night. That, of course, is the other thing. I have some clients, don't tell anybody this, but if they called me in the middle of the night on Saturday night and said, oh, we have an emergency, it's like, I'll be there in 15 minutes. I don't have many of those clients. So, we said a lot of things here, but let's get back to you have a mill, you have a lathe, you're not afraid to use them, and you're trying to make a buck. I think you have to pick one of our methods, tune it up a little bit, consider your labor, consider the machine, consider your consumables, and that's how you have to start your pricing strategy. It's going to be different for everybody, depending on where you're coming from. There are a lot of projects where, here we go. What if it's part manual and part CNC? I still think it's machine hours plus operator. If it's I don't separate them. So if we're on the machines, if we're in the shop on the machines for 10 hours, I don't care if it's a CNC machine or a manual machine, within limits. And you could make the argument, oh, good, I'll just do everything on the manual machine and it'll take longer and I'll make more money. It doesn't work that way. The other thing you have to do is, and this is probably the biggest thing, is you go to see a client or potential client, you have to sit on their side of the table and help. You're not there to make a part. You're there to solve their problem. And if you take their point of view, look at their problem, and help them solve the problem, perhaps by making parts, you will have a friend and customer forever. And that's the way to go. A lot of times you'll hear small businesses start, and the proprietor will hit the road with business cards and sample parts and make contacts and do that, basically doing sales. You will find that once your business starts, if you're doing it right, you're going to stop that. You'll never have to do it again, because word of mouth will bring you so many clients you won't believe it. Protium says, at the end of the day, the relationships are the only lasting competitive advantage. And I agree with you 100%. I have clients that go radio silent for 5 years. This happened just recently. I have clients that go radio silent for 5 years. All of a sudden they pop up. Hey, we need this thing. Okay, fine. It's like we never stopped. It's like we were doing stuff all along. So sit on your client's side of the table and look at the problem. Now, here's another thing that's very, very, very hard to do when you're starting a business. And I keep a reminder of it right here. So you guys on video, you get to see this before I explain it. This is the most powerful word that we have. This is the word no. Notice I'm not teaching a course in sales. This is not the word yes. This is the word no. And or more zeros. We'll get to that. You can't do everything all the time for everybody. At some point, you will be unable to turn out quality work for anybody. So when a job comes in that is not going to add to your reputation, skills, your customer's success, you have to evaluate that and say, I'm not the right guy for this job, but Joe is, and send him somewhere else. Okay. That's one way to say no. Say, I'm not the right guy for this particular work, but Joe is. Let me hook you up with Joe. The second way that's also known as ends. Yeah. Evil. Okay, let's get on to that one. The other way to say no is, how much money would it take for me to want to do this? You say to yourself. It's like, boy, normally this would be a $2,000 job, but I wouldn't touch this for less than $20,000. So you say to your client, it will cost you $20,000 for me to do this. That's the quote. That's called saying no with zeros. Now, again, Dale and I were talking while we were both working in the shop, and he relayed to me a time when he did that. He didn't want to do this particular job. It was wrong for whatever reasons. And he said, oh, no, just imagine a $2,000 job. And he said, no, he didn't say no. He said, $10,000. And the guy said, I'll be right over. So you have to be careful. You have to mean it, but you could say no by increasing, moving the decimal point over. And then sometimes your client will come up with a number that there's some unspoken communications that happens. Like, for example, your client's going to say, yeah, last time we did this, we paid this much. Let's just make up a number, $15,000. Last time we did this, it cost us $15,000. That information is platinum to you, okay? That's huge. So if you say, well, this time it's going to cost you $15,000 too, you might have an instant, like, sold, we'll get right on this, and that might be fine. You might say to yourself, holy crap, that's a lot of money. And you might say, well, we'd like to quote you, $10,000, thinking it's already high, and they say, and they're happy, and everybody's happy. And then sometimes the client's going to say, last time we did this, it cost us $10,000. And you could say, well, that's not a lot of money, and it's not maybe what I would charge, but this is a good customer. I want to help them. I'll tell you what, I'll do it for the same amount. Again, you have to decide what to do. But the number one error for a new person is undercharging. I'll never forget when I started doing my consulting work in antennas, a friend of mine who was a consultant for years at that point said, let me look at your rates. And I showed him my rates. He said, he looked them over. He goes, yeah, okay, yeah, yeah, double these rates. I'm like, what? He says, yeah, double these rates. You need to be at double what you're charging. Well, I had a lot of respect for this guy, and I did. I doubled my rates. The next clients that showed up, I showed them the new rate sheet. You should have a rate sheet. And they didn't even flinch. They didn't blink. And thank you very much to my good friend for telling me to do that. It saved me a lot of adjustment time. So that's another thing you could do as a person starting out, is go over your rates with a mentor and make sure you're not undercharging. I think we covered it. Yeah, Prodium says, and you will undercharge starting out. It's a guarantee. So just try to learn the lessons on the jobs you can afford to lose a little bit. Yeah, there's no teacher better than experience, but just try to get a mentor. Try to get somebody to help you out and double check the sanity. And I think that's a good way to go. I would rather do a job with somebody I like and respect and care about, such that at the end of the job, they got value, I got value, and they're still happy. Every now and then I don't want, if I find myself saying, I don't like this person, I don't like this job, there's a tendency to want to go, yeah, it's going to cost you all these extra bucks. You know what? I'm at the point now where I just say no, and have a nice life. Rommel says, could be nice to discuss customer tricks to get lower prices in the job shop engineering service world. I have a couple. Hang on. Podium says, but sometimes they might come back with a number way bigger than you were quoting. Yeah, it happens. So now I'm talking to the customers. Okay. I was talking to the shop guys. Okay. Now I'm going to talk to the customers. You want to get a low price? I'll tell you how to get a low price, or I'll tell you how to make the transaction more efficient, which is really what I'm trying to say here. Get as much detail as you can before you go asking for the quote. If you have a drawing, if you have a good drawing, you are miles ahead. So, if you're showing up at this shop with a verbal description of a thing that you don't fully understand, strap in, because it's going to cost, it's more work for them. It's going to cost you a bunch. If you show up and say, here's what we need. Look, we have a drawing. If we're happy to accept suggestions to change the drawing, we think we want to make this out of Inconel 737.2. I made that up. You're miles ahead talking to your shop, okay? miles ahead. If you confess, you go to the shop and you do need help, you don't have a drawing, you be right up front with all of that and say, look, again, now you're the customer, but you're going to sit on the side of the table with your shop, okay, with your problem solver, and say, look, we need help because we're not good at this, but we want you to do it. We want you to do the job. So if you could help us out, we'll help each other. You'll get the job. Everybody will be happy. So you see the same thing. You're going to go sit on their side of the table. I think that's a really good approach also from the customer's point of view. Quentin says, after my first job, I sent the invoice and my customer paid it within 5 minutes. By the way, those are the customers you keep. Not sure if I was too cheap or he was just fast. I still made back about 50% of the cost of the machine on that job, so I was happy. Fantastic. Dale says, always ask for the 3D model if they have one. It can really save your ass. We're spending a lot of time on this, but it's worth it. We're in a 3D printing world, okay? So a lot of people think they designed something because they have a 3D model. And there's a lot more that goes into the design of something and a drawing other than the physical 3D representation of it, okay? There's tolerances. You have to be within tolerance. You're welcome, Dylan. There's tolerances, there's materials, there's surface finishes, there's dimensioning, blah, blah, blah. So if they have a 3D model, which they might have it, especially if they walk in with a 3D printed version of this thing, get that data from them, and then you can start quizzing them on what's important and what's not important. Okay? Okay, so the other side of that coin is the customer shows up with a drawing. Hallelujah. And it was done by, tell me if you've ever seen this, it was done by the new kid, and everything has a dimension, and all the dimensions have 5 decimal places. Do you ever see that one? That's a good one. And again, you're going to make a friend if you get on their side of the table and you say, listen, every time you put a 0 here, okay, every time you put a decimal place, you're multiplying the cost by 10. Let me show you how to do this. Do you want to spend time doing that? It's up to you. But you got to start asking questions at that point. Josh says, at least it was the new kid and not the senior who should know better. Yes, it's true. Then there's all sorts of fun stories about stuff like that. But if you help somebody out, you're going to make a friend, you're going to have a client for life, and you're done advertising. That's the best thing. So I hope we answered some questions for especially for the person I'm thinking of who started the conversation. And it's a good conversation. We should have it some more. All right. I think we did it. Steve says we should do a part 2. Okay. We'll do a part 2. 2 months from now, maybe. Just bug me. Oh, excellent. Yeah. So Evils points out that Adam Demuth has some good videos on how design affects cost. Yes, he does. I remember them now. Definitely excellent videos. And Protium says, I'm happy to share the old quoting spreadsheet I got from a coworker years ago with anyone. That's very nice, Protium. And Steve says, that would be cool, Protein. I know what you meant. So, Protium, if you could put that into machine shop, which channel should we throw it in? I want to pick the right channel so it doesn't get lost here. You guys tell Protium. Oh, reference shelf. It can go to reference shelf. Self-employment or reference shelf or both. Okay, there you go. How's that, Protium? Did I mention that Protium does a great job on stuff? He did work for me that was Chef's kiss. Beautiful. I just want to point that out. Hashtag not sponsored. Okay. So let's talk about, see the gear shift there? You're welcome, sir. I meant it. Let's talk about standards. I was motivated by a recent video that I saw, which I have to dig up the link. I'll put it into the description. If I don't do that, yell at me. But it was a video about the change in the SI definition of the kilogram. So I will leave it up to you to do the deep dive in Wikipedia on what SI units are and, how standards are set. But I want to talk about standards in general. You can't swing I don't want to offend anybody. You can't swing anything around here without hitting a measuring device, right? So you pick up a measuring device. This one measures in inches. Sorry, evils. This one measures in inches and in millimeters. Well, how do we know that this is accurate? Yeah, that's right. Evils correctly says in millimeters and 25.4 millimeters. Yes, that's exactly right. So, we run around our shop measuring things, and I think most of you know that there's such a thing as calibration, right? So here's a set of gauge blocks, which we'll talk about, and it has, these calibration stickers on it. And sometimes you do work where you are required to track the calibration of the tools you use. Our good friend in Japan, Bakafish, he gets some fancy, cool tools cheap on the local market around Tokyo because they have a rule that every tool has a serial number and a certificate, and it's traceable, and after this amount of time, it is junk. And we're like, junk? So it ends up on the used market, and it's such a deal. And there are certain jobs, aerospace, NASA, where traceability of everything is really important. And then everything else is in between. But I'm talking to the small shop guys, right? You have a caliper, right? I'm sure you guys on the audio podcast can see this. Here's my Mitutoyo caliper. This is, right? How many of these do you have around the shop? I think we own 1, 2. Maybe we only own 2 of these. But of course, we have a dozen other calipers. Quentin says, I have spent so much money on Japanese, quote, junk, close quote, that Bakafish pointed out to me over the past year. Yeah. And Steve says, no wonder everything out of J.A. Pan is skookum. It is. So they don't exactly wear stuff out. But you pick up this thing and you zero it. Everybody has to know how to zero it. And then you hit the 0 button, and now it's measuring. Yay. It's perfect, right? No. So we have to trace our tools to a standard. As a small shop, what do you do? I'm going to take you from your calipers, okay, all the way up to the international standards. Shall we do that together? I think we shall. So, no, evils, you do have to buy a new one every time. You just send me the old one, and you'll be all set. I'll be able to get rid of it for you. So if you're in a small shop and you have your measuring tools, we're just going to use our Mitutoyo caliper as an example, okay? You might not, depending on your tolerances, you might not need anything else, and you might trust your caliper. If you're doing work that has to be within 0.010 of an inch as at the outside, and this is not a derogatory statement. Let's say you're a woodworker I like you guys. You know, if you buy a Mitutoyo caliper, you're set for life. Okay. But now you get into machining, and now you're working to 1/1000th of an inch. And yes, I'm not using SI units yet. So what do? Well, you can go out and you can buy a couple of gauge blocks or a couple of gauge pins. So just by way of an example, you know, here's a 1/2 inch gauge block, Mitutoyo. There it is, 1/2 inch Mitutoyo. And you treat this like the wonderful standard it is. And then every now and then you put your trusty Mitutoyo caliper on it and you read what it says. Mine is reading 50 millionths under. Or another way to say that is 1 digital count under. And oh, by the way, when I let go of the unreasonable pressure I was putting on it, it's reading 0. Okay. So you say, okay, I now believe that caliper, and maybe you buy a 1 inch gauge block, and you do the same thing. And it says 1.0000 inches. So now you're starting to believe. Okay. Oh, Robin said, thank you, Robin. Robin's yelling at me. Check your gib adjustment on your calipers. Yeah, there is a gib adjustment, by the way. There it is. There's the gib adjustment, 2 little screws. Of course, I don't do that. I send these to Pennsylvania. I have a guy in Pennsylvania who adjusts these for me. So you just spent maybe $50 on 2 gauge blocks, 2 good gauge blocks. You take care of them. You 3D print a little box for them, and you put them in the drawer. Congratulations. Now you're doing more work, and you need some more, you know, measurement dynamic range. So you might go out and buy more gauge blocks. But so here's as an example. This is a I don't know what they call these, a small set of gauge blocks. So this has a selection of gauge blocks from 2 inches down to 0.625 inches. If you're in metric land, you can. Quentin says that's a micrometer test set. Okay, cool. And you could buy one of these. Well, this is going to cost you, I'm going to guess, you guys with the catalogs handy can tell me if I'm right. By the way, there's a piece of VCI paper in here. Okay. This is going to cost you $300, more or less. That's why I'm closing it, Tuck. Tuck's waiting for it to all fall out. And now you have your shop's master length reference set. Well, time goes on, and now you're doing other stuff. So now you go out and you buy gauge pins. So gauge pins are like gauge blocks, except they're pins. And oh, by the way, they come in big boxes with a whole mess of pins, and they might be a 1/1000th of an inch apart. So Steve says, don't touch them with the fingies. So yeah, you got to take care of them. You got to wipe them down, and your investment is worth it. But when you buy these things, right, and you get these from Mitutoyo, they generally will come with a certificate. And I don't have a certificate to show you right now, but if you buy it brand new, sometimes it's an option. Like when you go to McMaster Car, I remember there were 2 prices. You could buy it with the certificate or without the certificate. And you might say, oh, I'm saving $20 if I get it without the certificate. That's fine. But if you get it with the certificate, it says these blocks are certified on this date to be within tolerance. And here's the errors of each of the blocks. It's pretty fancy. And now you have a certificated, calibrated set of blocks. But there's a question. How do they know? Yeah, Steven says aerospace shops require this. Absolutely. And if you're doing aerospace work, not only are you going to, you know, write down the serial number of the calipers you're using, you're going to write down the gauge block serial numbers that you tested them with, the certificate number. There's Dale's certificate of inspection for some of his blocks. So let's say you're going along, you're doing your thing, and your customer says, we need this to be traceable. And then the finer blade on that knife, or the finer edge on that blade, is, we need that to be NIST traceable. NIST stands for the National Institute of Standards and Technology. And how do I know if it's NIST traceable? Well, your certificate, the Mitutoyo or whoever sold you your blocks had it measured by a lab, had their standards measured by a lab. Well, you go to that lab, okay, and you knock on the door, and you say, excuse me, I need to trace this all the way to NIST. Are you the NIST? And they say, no, we're the Acme Calibration Lab. Come on in, but don't go in that door. Why? Because that's a temperature-controlled room. Oh, now you're in the calibration lab. And you say to them, I understand you calibrate the standards for the company that sold me my blocks. Okay? And we're getting a bunch of links to, yeah, super cool tour of NIST from Machine Thinking. So ultimately, you're climbing a pyramid, right? And you're a pyramid of precision. And ultimately, you're going to end up in the basement of the NIST. Go watch that video that, how do I point? There, no, this way. Go watch the video that Protium just posted. And it's a deep rabbit hole and so worth it. Well, it turns out that ultimately you end up in NIST, and then you say to NIST, how do you guys know how long my thing is? Don't take that personally. And they will tell you that, well, we have the artifacts, which are the standards, and we can compare your thing to the artifact. So let me just show you a picture. Actually, yeah, that's right. Here we go. Hang on, we're almost there. There it is. That's the one I want. Okay, so here is a picture. If you guys are on video, you can see that. This is the end of a 1 meter bar, which is the physical meter artifact at the NIST. And what's not obvious is that there's a little scratch mark inside that V groove right there. But this is a bar that has a cross section that looks like a fancy X, and it is actually a teeny bit longer than 1 meter. And then there's these 2 scratch marks on them, and those 2 scratch marks are exactly 1 meter long. So you hand your thing to them, and they measure your thing, and they compare it to that bar, and they give you a number. And by definition, you now know how long your thing is. And now you say to the NIST, I know this is kind of a personal question, but how do you guys know how long that bar is? And this is where it gets interesting. Wow. Evil says it's called a Tresca, that shape, a Tresca section platinum indium bar line standard. So yeah, Evils, that's too much history. We're not going to talk about that. We're going to give you homework. There's a book called, I've talked about this book before, called The Perfectionists. And it's also a audio book. And if you have not read or listened to, or both, I recommend both, by the way, The Perfectionists, go get it. It's awesome. So, yep, Simon Winchester, exactly correct. It turns out that please stand by. I'm looking for the right slide here. There we go. They started the SI system decided to define the meter according to this thing, which is the speed of light. Okay, so they take the emission of a certain isotope of cesium. Okay, and they know the speed of light, and they know the wavelength of cesium, and they say this many wavelengths of the emission of that cesium atom, which is, I think we decided it was a green color, is going to be the length of a meter. There we go, Stephen, The Perfectionists. That's it. You'll love that. That is awesome. That's an awesome, and the audiobook is outstanding. I sometimes audiobooks are not great. It's outstanding. So let me see. I have a slide for you which talks about no, that's not it. That's it. Okay. So the speed of light is a constant. It's 299,792,458 meters per second. So that is the number. And they call that a constant. And now they back calculate to meters from meters per second by using a particular emission from a cesium atom. And now they're able to define what a meter is. And then they check the physical artifact. They measure the physical artifact using a technique which directly traces to that wavelength. And that is how they get a physical standard from their theoretical standard. So Evils Evils just pointed a picture of the kilogram standard, although that isn't the standard. That is a copy of the standard. But back in 2019, they were defining the kilogram, and this is the thing that I want to share with you the most. Let's see if I could find it. No, where is it? Get rid of that. I have a photo here I want to show you. No, that's not it. Sorry for this outstanding example of, here we go. Okay. So up until 2019, the kilogram was measured as referred to a particular artifact, and the picture on your screen is the artifact. Now, if you're on the audio podcast, it is a cylinder, what we would call a square cylinder. So it's about the same diameter as it is long. It's made out of a iridium platinum alloy, I believe, and they define that as the kilogram, and everything gets compared to it. But one of the problems that happened in doing so is that every few years they got together on an international basis and they measured all the standards against each other. literally all the countries would show up with standards. One person would carry the standard, and they started measuring them, and they were diverging. So the letter K there represents the what we call the big K, okay, the standard, and then all of the the sister standards were starting to change over time with respect to to big K, and they didn't know why. So what they decided to do is redefine the kilogram from basic fundamentals instead of from an artifact. And take care, Quentin. And they turned around how they do the definition. So if we go back and look at the defining constants, there was a couple of ways to do this. One of them was with Planck's constant, and they could use what's called a Watt balance to measure the mass. Or another one was to use the Boltzmann's constant. I'm sorry, not Boltzmann's constant. Or Avogadro's number, or Avogadro's constant, which is measured in moles, which is how many atoms are in make up. I forget exactly what it is. How many atoms make up a gram? But anyway, they had a contest, basically, and they had two groups, one that went and based their measurements on Avogadro's number, and one that went and based their measurements on Planck's constant. And they converged. And basically, using completely different techniques, they came up with the same answer, and they decided that that's how they were going to redefine the kilogram from basic principles. And one of the key tools that they came up with is this sphere made out of silicon. So if you take silicon, a very pure silicon of one isotope, and you make a perfect sphere, okay, how many numbers does it take to define that sphere? And the answer is 1, the diameter. So thank you, Fermion. Fermion's correcting me. So the diameter of that sphere is the only number that defines the shape of that sphere, as long as it's spherical. And spherical is easy because it's a differential measurement. You're checking one radius or one diameter to another diameter to another diameter. But let's just assume that they know how to get to a sphere, which they developed very carefully. And let's further assume that it's a very pure material, which is of one isotope. You now can go from the diameter of that sphere to a number of atoms. And by doing that, you can calculate your way to its mass in kilograms. And that is now how you get to the kilogram. Now, here's the cool thing. You now get to the kilogram without needing a physical thing. That wasn't true before 2019. So before 2019, if you wanted to know if this thing, okay, and a lot of you think that this is my internal standard for the kilogram, and I'll let you think that for a few minutes. This is actually pretty heavy. If that thing, you compare it to the kilogram, if it's the same, it's a kilogram. Well, now it's the other way around. You could take that sphere, you can measure its diameter, you know how it was made, and now you compare that. You just got your kilogram, and now you can compare that with your thing. So you could take all of those physical artifacts at the National Institute of Standards and Technology. Eric, close your ears. and destroy them, and you haven't lost your standards. You could build back from first principles and be right back in business. Isn't that cool? So, from your lab to the NIST is actually a measurable path, if you'll pardon the pun. And there are a bunch of videos out there, but I had the honor of working on a project for NIST with respect to one of their measurement machines that does a comparative measurement on gauge blocks. And you may recall that we had some pictures of this artifact. Just pulling the tape off it. This was a lapping job that I did on 52-100 steel, and you may recognize it that this is the toolmaker's flat that I made. And it turned out that the material that I made it out of and the heat treatment that I chose to use on it was because it was exactly identical to what they needed. And I actually sent them an artifact of what I did, and we're in the middle of that. So Fermion says it's NIST, pronounced like pissed. NIST, of course, but they're not pissed. So the path from your Mitutoyo caliper to the international standards of length in this case, or if you're dealing with scales of kilograms of weights in another case, or even in terms of electrical calibration like amps, the path to the primary standards is not that long. Okay? But I think it's important for you to know how that works. And it might be 2 jumps until you're in the basement of NIST, or it might be 20 jumps before you're in the basement of NIST, but it all lands in the same place. Somebody asked me what kind of reference do I use in the RF shop for frequency. So here in my hand is an example of an oscillator. This is a reference oscillator that we use. This is not the exact one that I use because it's in a piece of equipment, but this is a rubidium standard oscillator. Now this oscillator, thank you, Evils. This oscillator is accurate right out of the box. It's accurate to 1 part in 10 to the minus 9th. That's 1 part per billion. And then you can adjust it with respect to an external standard, and it will hold 1 part in 10 to the minus 12th, which is a trillion. 1 part per trillion. And, it weighs about the same as, like an iPad. It's about the size of a small, what would you call that? A disk drive. It looks like a disk drive. And this is in my hand, and it was surplus on eBay. So in our lab, we have a standard that we use for 10 megahertz. That's the standard frequency in the lab. And that keeps itself calibrated to the GPS satellites, and it's accurate to 1 part per trillion. And I find that rather amazing. Now, if you trace that, it also goes all the way back to the NIST and fundamental standards. So this is rubidium based, whereas the frequency standard for the whole system is cesium based. So this in my lab, this gets locked to GPS. GPS in turn gets locked to the cesium time base. So Carl says, can you use GPS satellites as frequency standards? Yes, you could. That's what the box in my lab does, and I could shoot you a picture of it. But So GPS is part of distributing time and frequency reference, which is pretty cool. All right. We have taken you from your basement all the way to physics. And Evils was showing this picture. I think this is worth looking at. Let's see if we can't decode this. The outer ring on this diagram is all of the physical constants, and they lock in the inner ring, which is the things we measure. Some of these you recognize: the ampere, the meter, the second, the kilogram, the mole, the candela, and I don't remember what K is. Sorry, that's homework. Oh, Dale asks a really good question. Dale says, what is one of those cheap, quote, atomic clocks used for a reference? I love this. So, if you go, I actually had one, it broke, but if you go onto, Amazon and you buy one of these wall clocks and it says radio locked or radio, it says atomic clock. This is super cool. It's listening to a radio transmission. That radio transmission is at 60 kilohertz. RJ, that's awesome. WWVB is the transmitter that transmits on 60 kilohertz reference frequency and time. It's mostly used for time standards. And it is automated. It's not there's no voice on it or anything. It's a data signal. And these inexpensive things can tune in to 60 kilohertz, lock on to this signal if they're good enough and if there's not too much noise, and calibrate themselves. And it works. And it works great. And about 20 years ago, they said, this is working, everybody's using this. Let's crank the power up. And I think they cranked the power up by a factor of 10 or 5 or something. And it's still cranking. So that's WWVB transmitting on a frequency of 60 kilohertz. And that is how your cheap atomic clocks get their reference. Okay? If you're a ham radio operator, you already know the answer. WWV transmits on a frequency of 2.5, 5, 10, 15, and 20 megahertz from Fort Collins, Colorado. Why do I know that? Because I've listened to that announcement at the top of the hour 1,000 times. And WWVH is a sister transmitter in Hawaii, and it transmits on the exact same frequencies. And they're all of these, by the way, are frequency locked to the national standard, and that frequency standard is generally distributed via GPS. So once again, your cheap clock that you just bought on Amazon goes right back to the basement of the NIST. Isn't that cool? So, there you go. Go read The Perfectionists. Go watch the videos from 12 years ago. Veritasium did a good video on the kilogram redefinition. There's a super good video, which I will get you the link for, that I just watched and enjoyed immensely on the kilogram redefinition. But the thing I want to leave with you is this. When they did the kilogram redefinition, they pulled together scientists from I don't know how many countries, many countries. And they all had been working on the problem independently and communicating to each other, and boiled it down to this approach that led them to either, depending on the Planck constant, or sorry, I'm having a blank here. But the Planck's constant is ended up being the thing that they depended on. They all got together to Avogadro's constant. Thank you. They all got together. They voted on how the standard was going to work. And in 2019, all of these countries said, yes, unanimously, let's do this thing. This is a huge deal. The world was working on physical standards up until that point for the kilogram. And it was a beautiful example of international cooperation. And this, the video that I'm referring to, which again, I will get the link into the description and put it on the Discord video. The people that they interviewed were multinational in each country's office. Like if you go to the NIST, you're going to meet people from all over the world that work there. Okay. Either temporarily or continuously. And it was the same all over the place. And it was magnificent to see the cooperation to arrive at a scientifically proven, well-designed, thoughtful system for maintaining our constants around Earth. I really like it when that happens. And I think it's awesome. And that's why I get excited about standards. We have a joke about standards, that the great thing about standards is that there are so many to choose from. But in this case, it all drives down to one answer. So with that, I'm going to say have a great rest of your day. We're going to jump over to the after party roundtable if you want to hang out. And we'll have fun. Don't forget, the only standard for flat is flat. So if you need something flat in your life, head over to PFGstones.com and we'll take care of you. So get flat, stay flat, and we will see you next week. Have fun.